Well, welcome everyone. I wanted in this talk to discuss with you some unique investigations which were carried out over a century ago by two well-known members of the Philosophical Society, Annie Besant and Charles W. Leadbeater. Their work extended from about 1895 and finished about 1908 with a number of further investigations by Leadbeater leading up to about 1932, shortly before he passed away. Now, the importance of their paranormal investigations is twofold. First of all, they make predictions about the structure of matter, which, if it were confirmed by experiments in particle physics, would usher in a new revolution in the subject. Secondly, they demonstrate that the human brain can't be the source of all possible information about the physical universe that is provided by the five senses. So one implication is scientific, and the second implication is philosophical, implying a kind of refutation of the prevailing scientific paradigm that the physical brain is the source of all information about the universe. So let's go on quickly to the next slide. During the 1960s, particle physics underwent a strong development in experimental field with the use of high energy particle accelerators. The plethora of subatomic particles were discovered and were eventually classified according to their quantum properties. And what you see are the various patterns or families in which these particles could be grouped according to certain quantum numbers which specify their properties. I won't try to explain that. I don't have time. But here you do see what is called the eightfold way, which really refers to the fact that in some of the subatomic particles, so-called baryons and mesons, they formed groups of 8, families of 8. This pattern was formed by particles with higher spin-free halves. And in fact, the pattern is that of the Pythagorean tetratis. Now, the problem was facing physicists, what was the meaning of all these patterns? Patterns generally indicate some fundamental structure or regularity, some principle which is generating by some sort of combination or permutation of properties. All these particles which make up these patterns. And eventually in about 1964, Murray Gell-Mann and George Zweig proposed a quark model in which two strongly interacting particles called baryons were made up of three quarks, and mesons, which are particles formed by the decay of baryons, ultimately into a proton, were formed of a pair of bound quarks consisting of a quark and an antiquark. So right. So it turns out that this pattern of either two combinations or combinations of three could generate then the octets, the various families of 8, and the decuplet of subatomic particles. That but these particles were only strongly interacting, which means that the forces that they exert are such that they decay extremely quickly. But we know that things like electrons and muons and other particles have existed. They were known to exist long before all these other particles came on the scene. And so the question was, how do both the strongly interacting particles, baryons and mesons, and how do the weakly interacting particles, the so-called leptons, how do they relate to one another? Eventually, the baryons and leptons were classified into a certain pattern, which you see here. This is not a theoretical scheme. It was assembled painstakingly by many experiments in high energy physics labs. And eventually, during the 1970s, it became recognized or became established. Now, there wasn't just one family of quarks that had been originally proposed by Gell-Mann and Zweig. There were, in fact, 3 classes, or 3 generations, as they're called now. And these are the generations. So there are 6 quarks ranged in 3 generations of pairs. They're called up and down, charm, strange, top and bottom. Associated with them are neutrinos, are the leptons, which are, for example, the neutrino here and the electron here, and their more massive counterparts, which have been established. Now, the neutrinos were once thought to be massless, but now experimentally there are signs that they do have a very, very small mass, although it hasn't been established yet. It is too small for experiments to be able to measure. Though in the future they probably will be soon. Okay, so we have therefore 3 generations of quarks and leptons, and we also have the particles that carry the forces or transmit the forces, the four main forces which are known: electromagnetic, strong, and the weak force. um, and this has been established to be unified now in what's called the electro-weak force. Now, the only force which is missing here is the gravitational force, the force which holds the planets together around the sun, orbiting the sun. So that doesn't fit the standard model. That's still discrepant and has to be explained by the standard model. So the model which has been established is purely experimental. It excludes the gravitational field, and it has other problems with cosmology, with what is known in cosmology, and most physicists agree that the standard model is not the end, it's not the final answer whatsoever. It is only the beginning of the final answer, you might say. The first generation is what the first generation of quarks, leptons, is what is found at low energies on the Earth and in the universe at large, certainly in the solar system. The other generations have only become relevant in the physics of matter when it's accelerated to the speeds that are created in high energy physics labs. That's not altogether true, but anyway, it is the first generation of up and down neutrinos, up and down quarks, neutrinos, and electrons, which play a part in the normal properties of everyday matter that we know of, atomic nuclei in the normal ground state. So we're familiar with the scheme of atoms, with the Bohr-Rutherford model, as it's called, of atomic nucleus surrounded by electrons, clouds of electrons orbiting rather like planets around the sun. That is quite realistic to only a degree. It is a classical view of the atom, not the quantum view where the particles now behave as probability waves, instead of like little balls. But it certainly still works. It's certainly valid in its own right. Now, the proton and the neutron, which makes up atomic nuclei in the center of the nucleus, they are made up of either two up quarks and one down quark, or two down quarks and one up quark. Sorry, I have clicked. I shouldn't have. Right. This model, the quark model in the quark theory of quarks has been very successful. Has a few problems still to be solved in it, but it's left some number of questions unanswered, like why are there only 3 classes of quark, 3 generations? And a few brave physicists, including myself, have tried to proposed that quarks may be made up of smaller particles called subquarks or pions. I proposed a composite model of quarks back in 1980, it published in Physics Letters. It was approved of by Professor Salam, Abdus Salam, who won the Nobel Prize in Physics that year. I extended one of his theories to take into account subquarks or compositeness of quarks. Experiments haven't yet found any evidence of this yet, haven't uncovered any subquark structure. The quarks still seem to behave, according to present day experiments, as little points, little mathematical points, instead of as extended objects. But that is simply probably because I believe anyway that the particle accelerators have not achieved high enough energies yet in order to probe any structure that might be in quarks. So at the moment, it's still a suggestion which has been has a minority interest throughout the physics community. But there seems to be no pressing need yet to consider this possibility. There is some evidence for subquarks, for things smaller than quarks. And I gave some evidence in my paper in 1980. Unfortunately, that particular property or behavior can be explained by the theory of electromagnetism, what's called quantum electrodynamics. So there are alternative explanations of that property of quarks. So it's not the evidence, the experimental data doesn't provide unambiguous evidence, because you see it can be interpreted in a number of ways, and that and quark compositeness is only one of these alternative ways. In the 1970s, the mathematics of mathematical problems with quantum field theory, the appearance of infinities, things like that, mathematical singularities in the quantum field theories, that did lead some physicists to play around with the idea that perhaps the basic particles of matter are not mathematical points as they'd always been seen as, but perhaps were extended objects. And the notion of strings became developed. The strings were then, a certain symmetry was added to the string, so as to include all particles which, whatever their spin properties. So the super applies what is called supersymmetry, and it really is the mathematics of all particles, whatever their spin. So this generalization to any spin, any spin angular momentum, called supersymmetry, led to the notion of superstrings, which were divided into two classes, open and closed. And according to superstring theory, they're supposed to vibrate in a 9-dimensional space. That's what's required. That's the mathematical requirement of the theory in order for the theory to be mathematically sound, we say, for all mathematical problems which had afflicted quantum field theory up to that time, and all for those problems, so-called quantum anomalies, for those problems to disappear, the space had to be 9-dimensional. Now, these strings, I suppose, are joined can be conceived as in a certain way. As I said, they can be either open strings or closed strings, and the ends of the strings can join together, form closed loops, or the loops can break apart and form open-ended strings. And this would explain the different types of strings, how different types of strings can interact with one another. This is simply a joining together of strings and tying them together or splitting them apart. Okay, the 5 superstring types. There were supersymmetry research eventually reached conclusions that there were 5 different types of superstrings. They were, in terms of their mathematical symmetries, they were interrelated, and one of them turns out to be very, very important. And I've circled it here. It's called E8 times E8. In the late 1990s, it became realized, or superstring theorists came to the conclusion that all the superstrings were really all different forms of one type of superstring. And this is indicated by this little diagram where it indicates how they're all interrelated. There were all different forms of one type of superstring. And this is called M theory. But now the superstring doesn't exist in 10 dimensions, it has to exist in 11. But it turns out the E8 times E8 heterotic superstring is very, very significant from the perspective of what I'm going to talk about, which is, the anticipation of superstrings by the apparent anticipation of them by Besant and Leadbeater. Besant and Leadbeater were 2 early theosophists who conducted research using a form of what they called clairvoyance. We all know what clairvoyance is, but the form of clairvoyance they were supposed to have used doesn't apply to the average everyday world. It only applies to the world on the small scale. So they claimed that they could see in a certain sense very, very small things that certainly couldn't be seen by the naked eye. Now, this ability to see the very, very small is one that is described in the Yoga Sutras of Patanjali as anima. It's one that it's described as one of the siddhis or paranormal powers. Sanskrit word for it is anima, and it's listed in the sutra, in this 26th sutra, as knowledge of the small, the hidden, or the distant. Now, in the Uttara Tantra, which is a commentary by, according to Buddhism, Buddhist tradition, a commentary on the teachings of the Buddha by Maitreya Buddha, the future Buddha, according to Buddhism. In the verse 34 of this teaching, this Buddhist teaching, which actually comes from Tibet, it says that Buddhahood has a sign, which is the quality. One of the signs of Buddhahood is a sign of clear cognition, having the power of clear cognition. And one of these aspects of this power is so-called divine vision, which is the ability to see extremely distant and small things. So we have a parallel between the Hindu tradition about the cities, and in particular this one, and the fact that, and also the Buddhist tantric, well, not tantric, but rather the Buddhist tradition of paranormal psychic powers, both of which from both traditions, they make reference to the ability to see microscopic things. So let's see what Lebita and Besant saw. According to one of their publications, matter was ultimately made up of two sub-units, two basic units, indivisible units of matter. They called them the ultimate physical atoms. And one was a mirror image of the other. One was positive and one was negative. They called them positive and negative, but they never defined precisely what they meant by that. And I now know what they did mean by that, but I won't go into that. But they defined sort of male and female, a duality of male. Matter has a kind of duality, basically, on the fundamental level, of positive and negative, male and female. But their description of what they thought the basic units of matter had been anticipated by another individual, a American doctor, who practiced the healing power of color. He was a color therapist, one of the early pioneers of color therapy. In 1878, he published this book describing most of it is rather uninteresting because it's simply a sort of exposition of what he understood to be the physical, mechanical explanations of natural phenomena. But he also said that he had developed a form of clairvoyance through meditation, and this enabled him to see the basic atoms. Now here's a comparison between Besant's and Lebita's version of the basic particles of matter and what was Edwin Babbitt's atom. He thought this was the basic atoms of matter make up all the chemical elements. Besant and Lebita didn't believe that these were the particles that made up the atoms. But they weren't the atoms themselves. As you see, there are similarities, but there are slight differences. But anyway, the significance is that you have you have two different sources of this description. Slight variations, but enough overlap for one certainly to take an interest, for it appear to be significant. Now, the skeptic would say, of course, that Besant and Leadbeater simply sort of plagiarized this picture and turned it into this. But you see, there are differences, and which I can't go into, but these differences are important, and their work went far beyond whatever Babbitt described. This was the only thing that he was able to describe with the clairvoyance that he claimed to have. So to describe quickly each of these, well, the UPA here is made up of 10 closed curves. They never touch one another. They remain completely separate, and each is a helix made up of 1,680 circular turns. Positive and negative UPAs, these helices, they spiral in an anti-clockwise and a clockwise sense. Now, a helix is simply can be regarded as circularly polarized wave. It's a superposition of two plane waves which are 90 degrees out of phase. Well, when you superimpose two plane waves like that, you get a circularly polarized wave, and that can oscillate either with anti-clockwise or in a clockwise sense. So that if it oscillates and rotates in an anti-clockwise sense, then the other one, the mirror image of that, would be a clockwise sense. So we can think of the positive and negative UPAs as made up of helices, which are in fact circularly polarized waves, which are spiraling either clockwise or anti-clockwise. Let's now see some of the so-called atoms that they described. They classified them according to their morphology, to the appearance that they gave, that they had. There were 7 types: spike, dumbbell, tetrahedral, cube, octahedral, bars, and star. I won't go into the differences of these. Simply that I think it's clear that the names are referring to the roughly to the shape. Like a cube, it's made up of funnels which are arranged and project to 6 faces of a cube, you see, or to the 4 faces of a tetrahedron, 8 faces of an octahedron. This is what they mean. But there were 7 classes, and there were some elements which they said were exceptions to this, didn't fit any of these categories. These were hydrogen, what they called adyarium, because it was discovered in Adyar in India, occultum, what they called occultum, and helium, oxygen and nitrogen. They were the only elements that didn't fit the sevenfold classification. Here's some examples of atoms as they described. Now, because they are, it turns out, though they thought these were the chemical atoms, I'm not, rather than make that assumption, I've called them the micro-psi atom. Now, micro-psi is the term I give for this form of remote viewing of the subatomic world. I call it micro-psi. And so this is the micro-psi atom of uranium, the heaviest element or the heaviest naturally occurring element. Has a globe, central globe, funnels sticking out from it with all these little groups of particles, and then also spikes coming out of it with all this very complex grouping bound states of all these little points of light. These points were in fact the UPAs. Here's the gold MPA. Okay, so let's right. The gold MPA, right. Right. Now the interesting thing about this, is the following. As I'm going to come to this in the morning, I'm really anticipating what I'm coming to. But if you work out the number of points, if these points really were subquarks, which is how I've identified them, if they were subquarks, then according to my theory of what these micro-psi atoms is, or are, I should say, the number of these points should be equal to the number of UPAs, the number of UPAs that they counted in the micro-psi atom. And you find this is precisely the case. The common isotope of gold has nuclei which has 3,546 subquarks if you just do the accounting. And that's precisely the number of UPAs that were counted in the micro-psi atom of gold. And I make the point here that if they'd been using some sort of rule to make up the numbers of these little points of light making up, or UPAs making up all these atoms, if they fabricated some rule to make up all these populations numbers, then they would have to use the atomic weights which were available at the time. But if you look at the contemporary lists of atomic weights that were available to them, in particular 1905 one, just before they published their book, you find that the atomic weight of gold is 195.74. This would imply a UPA population, if you rounded up this number to the nearest figure, either 95, 195 or 196, this would have led to a discrepancy. You see, this would have led to to a different number than this, and this would mean that it would be this would then disagree with nuclear physics. But you see, this indicates that the fact that there is agreement with nuclear physics is telling us that they weren't using atomic weights. They weren't just simply relying on atomic weights to fabricate the populations of these points of light, or these UPAs. If they had, then there would have been a discrepancy in their populations between their counted numbers and the predicted numbers, or the number that I predict, that should be in of subquarks that should be in the nucleus of the in the nuclei of gold. Okay. Now, these microsite atoms were made up of all kinds of particles. And that was one of the problems that physicists, chemists and physicists looking at their work during right during the 20th century, really, up to about 1980. This created a huge problem for physicists who are familiar with the Bohr-Rutherford model of atoms made up of two distinct particles in the protons and neutrons, and then surrounded by electrons. It created huge problems because they did record many different types of particles. As it turns out, my work indicates that this class, these groups of triplets of particles are quarks. There are different excited states of quarks. Here's more examples. Anyway, now the periodic table has now gone up to, reached about 118 elements. The Besant and Leadbeater also classified the elements using, in the fashion of a Mendeleev periodic table. And this is what they came up. They classified their atoms, the atoms that they saw with microsi. They classified them according to their shapes into main groups, into 8 distinct groups. And there was a correlation between the shape of the atoms that they described and the position of the element in the periodic table known to chemists. Now, this was very interesting and required explanation. Of course, the skeptic would say, well, they just made it all up. However, there were elements that they described which hadn't been discovered by science at the time. For example, technetium, promethium, francium, astatine. You see, and yet they fitted them properly according to their shapes in the correct positions along with the right elements that belong to the same group of the chemist's periodic table. So that is stretching chance, I think, a bit too far. But the problem was that they also described certain elements like this, and this, 2 elements belonging to these 2 groups of their table, which simply did not exist. They had no place in the periodic table. It wasn't a question of them not being found. They simply could not be fitted into the periodic table. And so it was problems like this that really caused headaches for the few scientists which were interested in this subject. Excuse me a minute, I'm just having a problem here. Okay. Neon and what's called meta-neon are the 2 isotopes which two isotopes which Besant and Leadbeater described or published, discovering before they were actually found by physicists. This is what neon and the isotope meta-neon, what they call meta-neon, look like. Now, the fascinating thing is that meta-neon, the term meta-neon, which they used to describe what was a variation on the element of neon. This was in 1908, 5 years before Frederick Stoddy, English chemist, proposed the concepts of isotopes to explain the manifestation of different types of radioactive atoms, or various variations in radioactive isotopes. This term was used by a Nobel Prize winner, Francis Aston. In fact, not only used, but he gave Besant and Leadbeater credit for it, would you believe? In a paper he presented before the British Association for the Advancement of Science, he actually, in a footnote, he actually makes reference to Besant and Leadbeater's terms, meta-neon, in order to describe a form of neon, what he believed was neon. No, actually, it wasn't neon. He thought it was a new element. It turned out it was, in fact, a new isotope of neon. But at the time, he thought it was a new element. But the amazing thing is that he actually knew of the work of Besant and Leadbeater. When a philosopher called Ginevra Daza, who collaborated with Besant and Leadbeater throughout their investigations together, when he wrote to Aston, who had discovered this isotope, and later got Nobel Prize winner for discovering many isotopes using this mass spectrograph. When he wrote to him, Aston denied of any interest in philosophy. This is the letter he wrote to Ginevra Daza, the collaborator of Besant Leadbeater, in I think it was near 1943 during the war, saying that he simply wasn't interested in philosophy and didn't really want to discuss, answer the questions that Ginevra Daza had put to him about the fact that Leadbeater and Besant had discovered an isotope of neon 5 years before Aston had actually separated out the two forms of neon using his mass spectrograph, working with J.J. Thomson at the Cavendish Laboratory. Now, so this answer, of course, is highly disingenuous, because he's simply denying that he knew about the work of Besant and Leadbeater. But the fact that the footnote, as Jeff Hughes, a historian of science, a few years ago pointed out when he did some investigations, he found that this footnote, in the original paper presented to the British Association. He found this footnote still there, and indicating that he certainly knew of their work. So anyway, so that can you dismiss as just a curiosity, or else you can suggest that perhaps Aston somehow he knew of their work, and I think it was through the influence of J.J. Thomson, his boss at the Cavendish Laboratory, who was a member of the London Society for Psychical Research, who would have known through the grapevine that Besant and Leadbeater had published work and predicted the existence of certain isotopes, variations of elements. And he may have been put up to it by J.J. Thomson, who, as I say, had a lifelong interest in the paranormal, parapsychology, who was his boss. But anyway, it's his historical curiosity. Now, the problem with the view that microsite atoms are not atoms, the problem with the view that they are atoms, that they don't bear any resemblance to the Rutherford Bohr model of the atom. They appear to be broken up in chemical elements, in compounds. They appear broken apart. They're not. Their structure is no longer intact. I mean, it destroys the complete notion of the basic notion of the atom. They contain many different types of particles, whereas we now know that the atomic nuclei of atoms consist primarily of a proton and neutron. And there are also discrepancies, which we won't go into, I don't have time, discrepancies between the various molecules and their shapes, which you can read on the screen, which disagreed with what had been discovered in chemistry. Now, in order to explain these discrepancies, I presented in a set of books published a set of books over the years, 1980, 1996, 1999, and trying to explain the work and reconcile it with atomic physics and nuclear physics and particle physics. I also published some research papers in various peer-reviewed journals, which didn't seem to raise a lot of interest. But because they're on the paranormal subjects, that was to be expected, I suppose. It's still it's a subject which is still very much anathema amongst mainstream physicists. I had the work published also in, the work was also reported in the Times of India. This is a newspaper article. And someone I collaborated with during the late 1990s wrote a book describing his research. He was a Canadian Buddhist who claimed to have developed similar abilities, and he described through his researches, we confirmed the work of Besant and Leadbeater as concerning the UPA at least. He wasn't able to. Whether we did work together, he did do some work, but he didn't have his ability developed to the extent that they had. But he did confirm what Besant and Leadbeater said. This book is certainly worth reading. He has passed away now. But it does include his own work and the correspondence he had with me, and the work we did, the research work, experimental work we did when I tested him with various kinds of trials, single and double-blind trials. This is work which hasn't been published, but it has been now published in his book. Also, some academics have made reference to the work of Besant and Leadbeater. Include Professor Annika, University of Pune in India, and a professor of English, would you believe, in America, who referred to Besant and Leadbeater as two modern-day alchemists in his book on modern alchemy. I don't quite agree with his labeling them as alchemists. It was certainly, but it was his way of having to refer to them as clairvoyants. I think it was a sort of academically respectable way of that would appeal to academic readers, that he didn't have to refer to them as clairvoyants or psychics or whatever. So he referred to them as alchemist, as a kind of alchemist. Okay, this is the hydrogen MPa, egg-shaped, made up of six groups of three. I have looked at this and interpret this as a deuteron, stable bound state of a proton and a neutron. I've labeled these little triplets of UPAs. I've labeled them in this way. And the reason why I've done this is because I'm able to do this because I depicted positive and negative groupings of three. Positive and negative. Positive outward pointing and negative were inward pointing. And it turns out that when you compare the positive signs, positive and negative signs of these triplets with the electrical charges of up and down quarks, you find they are the same. In other words, positive triplets are positive quarks, are U quarks, and negative triplets are the negatively charged D quarks. The deuteron is in fact formed in the very first step in the nuclear reactions inside stars that generate energy. And so these objects are these heart-shaped objects. They are the basic UPAs. And I've identified the simplest microSci atom, not as a hydrogen atom, not even as a hydrogen molecule, which would be made up of two protons, but as a proton and neutron. And I believe what happened is that when they examined the hydrogen molecules, the two protons are brought together and they collided and they fused together into form a deuteron. Now, okay. All right, that's the labeling and explanation of the hydrogen MPa. Now, a journal was published, a magazine was, scientific journal was published in 2011 describing dibaryons. Now, dibaryons, the deuteron bound state of a proton and a neutron is an example of what is now known as a dibaryon, which are pairs of baryons fused together, bound together by the strong force. And this is a picture which I've rotated slightly, published in the journal, published in 2011 by a scientific research lab in Research Institute in Japan, showing a dibaryon, of which the deuteron is an example. As you can see, now I've rotated it, it does bear a resemblance. You see how the two triangles are interlinked in the same way as the lead beta and Besant depicted the simplest hydrogen atom, or what they thought was a hydrogen atom. So, right. So this is what I think is actually happening when they observed with microsci various atoms. They were not describing atoms as they were, as we know it, as chemists and physicists know it. What they were seeing is an end product of the atomic nuclei of two atoms undergoing a process of nuclear fusion, but in a certain way, at such a high energy that the protons and neutrons actually broke up. They actually split apart and became quarks. And so what's happening is that the protons and neutrons in one atom and those in the other atom all intermingle. They join together and intermingle to form the microsci atom. Because thank you. Because the subquark models predict 9 subquarks in a proton or neutron, it means that atomic nucleus which has a mass number of A, there was A protons and neutrons or nucleons, they would, if 2 of them combined, then the microsci atom is predicted to have 18A subquarks, which means that the predicted population of UPAs is 18A. That's the prediction. Now let's compare it with the data. This is a complete list of all the populations of UPAs. And you see there's 31 of them which have 0 errors according to the predictions. This is statistically significant. 31 of the 111, the sample 111 different microsci atoms that were described. When you plot the predicted and the observed populations of UPAs, they fall on a beautiful straight line. So that the prediction is supported by the statistics. Now, let us suppose that they'd used lists of atomic weights available to them then, about 1905 or so. Let us suppose that they'd use those atomic weights to create populations of UPAs. Okay, if you try and fit the data, you find the best fit for all these elements. There's 57 of them in this particular periodic table, 1905. The best fit is this, which is, and the difference from 18 is about 4 deviations, which is not very good. Whereas the prediction with if you then try and fit all these populations with the mass numbers, not with atomic weights, the prediction is this, and that is a much more accurate fit because it falls within the one standard deviation. And so the fit of the data of the psychic data to the mass numbers is better than the fit to the atomic weights. Yeah, but the mass numbers were not available to Besant and Lelebita then. They weren't derived. The concept of mass number was not available to them. It wasn't conceived then. In 1908, the nucleon hadn't been discovered. The neutron hadn't been discovered. So all these mass numbers only became established several decades after all their work was published. And so, but you find that the fit to the mass numbers is better than the fit to the atomic weights. This, I would suggest, is evidence that they did not fabricate their data, but that the data is fitting the real nuclear physics composition of atomic nuclei. Here are examples of calcium, and here's examples of other elements. Just to give a quick example, the arsenic and aluminium microsite atoms differ in that they consist of these groups here. There's 8 there, 16. And there are a total of 96 extra groupings here. This is amazingly consistent with the nuclear physics composition of the arsenic and aluminium nuclei, because the arsenic nucleus of them has 96 nucleons more than the aluminium one, and here they are here. Amazingly, they describe the psychic description, the clairvoyant description, indicates a difference between the two elements, which is precisely what the nuclear physics would suggest. And this could not be known to them because, as I say, the nuclear physics wasn't anticipated too long after, or wasn't established too long after. And one can actually show that the groups in question, the extra groups in question, are in fact conform to the quark model of the proton and neutron. When you compare the positive and negative types with the up and down quarks, which are positive and negatively charged, you find they are the numbers that Besant and Leadbeater gave precisely agree. They agree precisely with the prediction. So this is therefore what they described as a quark, a free quark. They were described as linked together by lines of force of a magnetic nature, blue lines going around, flowing through, joining them together. It's about what mathematicians would call the trefoil knot. The 2-3 and the 3-2 trefoil knot. The simplest torus knot. But anyway, now compare the scientific model of strings of subatomic, the string models of subatomic particles, which was worked on in the late 1970s, with these pictures taken from the first edition of their book Occult Chemistry. And you do find some similarities here. Here we have a string model of a meson, and here's a string model of a baryon, Y-shaped or a circular one. And here we have depictions of similar things, but now they're applying to the subquarks, not to the quarks. I suggested that the string model can be applied also to what are the forces binding together the subquarks into a quark. So here we have a close similarity between the two. Here is a picture showing a calculation done with a supercomputer done for about 2003. Sorry. Showing the energy density of the fields or strings, the energy density within the strings themselves. Here's the Y-shaped string here, and here it is here. And here is the depiction of a single group of 3 UPAs joined by lines of force which end in the strings, end in the UPAs. There's clearly there is a resemblance here, and these are contours of the energy density. So what we're seeing here is the fall off in the energy density as you move away from the center, and it's color coded. Now, this is simply what we're seeing is a string joining the three quarks, you see, and its energy density color coded. Here we have the UPAs bound by a single string. And the higher orders, you're right, the toruses making the toruses or the toroidal wheels of the UPA have a sevenfold structure themselves. They're windings of strings. They're like strings being wound in successive circles. Each circle or turn of a helix is another helix, and each turn of that is another helix. Each turn of that is another helix, until we get what were thought to be spheres, tiny spheres. Anyway, compare that with this. Here's a page from Nuclear Physics journal. Here's a page from Occult Chemistry, their journal, Besant-Lebita's work. And it says that he speaks of the higher dimensions of space being treated in this model, torus model, they call it. The model they have is that of the higher dimensions of space being circles. And here you compare this within this text. There are within each wire, 7 sets of coils, each finer than the preceding one. And so if you unwind the coils, we have nothing but an enormous circle of the tiniest marginal dots. So they're describing very similar, they're describing a pattern which is actually identical to the nuclear physics, to this particular model, a toy model, as it's called, a simple model, mathematical model of the high dimensional space of superstrings from this journal on nuclear physics. So I'm coming towards the end now, the last couple of page or two. Here are some discoveries and anticipations of physics that Besant and Lebita seem to have foresaw. They observed positive and negative triplets. That was the most ubiquitous type of particle that they saw in their atoms. And the quark model, of course, predicts atomic nuclei made of positive and negatively charged quarks. They described metaneon, 1908, then they were discovered by Aston in about 1912 with his mass spectrometer. Then they foresaw the string-like nature of the forces between quarks, between UPAs, and they seem to have anticipated various elements which hadn't been discovered at that time. These were the elements discovered later. So these were, I believe, the main reasons why their observations were genuine. The populations of the MPAs, they match the mass numbers rather than atomic weights. And that was absolutely impossible at the time because they didn't have any concept of mass number then. All the mass numbers of the atomic nuclei for all the elements had not been established. That only came several decades later. They reported several versions of isotopes, which hadn't been found then at the time, as well as several elements, and they described them with the shapes that fitted the proper periodic table, fitted the proper group of the periodic table. They also describe UPAs as string-like, as curves that fitted the superstring picture of closed curves. And they also predicted that the strings were winding around little circles, and there were 6 higher orders of these circles. And that fits the prediction of superstring theory that there are 6 higher dimensions of space. So finally, then, I suggest that the UPA is a real object, not hallucinatory, not invented, because of these reasons, and that UPAs are in fact the basic units of matter, which would mean that they are the constituents of up and down quarks, which means that quarks themselves are not fundamental, and that implies, therefore, that particle physics is going to experimenting with the new generation, perhaps in any new generation, or even perhaps with the present high energy particle accelerator at CERN, they will find eventually evidence that quarks are extended in space, have a structure, and then eventually they will discover perhaps that they behave as groups of free particles. And this will confirm the century-old psychic description of matter by Besant and Nedved. Thank you, ladies and gentlemen. That ends my talk. So I'll hand you back now to Nikolai.
Stephen, thank you so much for that. And my huge apologies for my sound problems. We did a dry run this afternoon and all worked well, and did one
yesterday. Yes, Eddie. Yes.
Yes. And I just sorted it out simply by restarting the computer, which is not the best solution, but huge apologies for the embarrassment as well. I think in summary, what you have shown, Stephen, is this: one of the well-known sayings by the masters, the adepts, is science is our best ally. And the ally of what? The ally of the perennial philosophy, the ancient wisdom, occult science. And what you have shown painstakingly is how modern physics can be shown, can be raised, can be elevated to shake hands with the occult wisdom, but it needs someone of your caliber and your commitment to do that. So without any ado, I see some raised hands. Now, I have all the time in the world. Can we extend to at least 7 o'clock? If that's all right with everyone. I know Bernard is dying to ask a question. Do you want to go first, Bernard, and then we'll go to Margaret? And I'm wondering if Stephen can comment on whether the strings and superstrings really indicate the need for further research in hyperspatial, hyperdimensional models of reality. Bernard, do you want to go with the question?
Okay. Thank you, Stephen, very much. I think we met many, many years ago, so it's nice to see you again.
Yes.
There are lots of questions I could ask, but I just want to ask 2 questions.
Okay.
One relates to what Eddie just said. I was interested, of course, in the references to higher dimensions. I'm very interested in hyperspatial models of mind. Now, of course, we all associate M theory with higher dimensions and these compactified higher dimensions. What I'm not clear of is whether the original theosophical texts are explicitly referring to higher dimensions, or whether they're just referring, you refer to having closed loops and things like that. That was my first question.
Oh, yes, they did. Yes, they did. Yes.
Oh, so they did explicitly talk about higher dimensions. That's very
or planes of nature.
Yes, they certainly they were referring to the fourth. They referred to the fourth dimension of space. This was a concept which was very popular at the time. It had been popularized by Howard Hinton.
Yes.
But they did refer to a fourth dimension of space, which was very popular at the time amongst everyone, you know. But they also referred to an extension of matter into higher planes. And this is where I think they made a fundamental error, which I can go into, but I don't know if you want me to go into that.
Well, maybe not if it would take too long.
It wouldn't take too long.
Questions. I mean, but I'm just quite, I mean,
I haven't answered your other question yet, have I?
Well, I mean, I wasn't sure though whether they explicitly talked about the number of extra dimensions, or they just in the way that M theory does, or whether they just talked about.
Oh, no.
No, okay. My second question, though, is more qualitative, and then you can decide if there's time to answer in more detail that first question. You've obviously focused on the way in which Besant and Leadbeater and others had clairvoyant insights into the nature of subatomic matter, you know, the atoms and things like that. But of course, the other great developments in physics at roughly the same time was the developments of quantum theory, which completely changed our view of the nature of reality, not just the atomic structure, but the nature of reality. Was there anything in the theosophical insights of Besant and Leadbeater, or indeed any other theosophists, which hinted at something to do with quantum theory?
Oh, yes. Well, there they were describing certain effects, which are quantum mechanical effects. For example, they described the hydrogen microsy atom as, they described it as spinning like a top. Okay.
Right, but did they, for example, we know there are all these weird qualitative features associated with quantum theory, like objects being described by waves rather than being particulate. I mean, did they have any of those more qualitative?
Oh, okay. You're asking, did they? I mean, they described. Their description really is very particle-like.
Yeah.
Which fits the the paradigm of 19th century physics. You know, Newton's hard massy atoms or the balls. There's very little in the description that I can see that is that refers to any wave-like notion, any wave-like behavior.
Yes.
You know, yeah. However, they do describe, particularly in their later experimental work, they described the certain atoms behaving, particularly the hydrogen microsy atom, behaving in what is in fact a quantum way. In other words, because a deuteron has spin 1, you see, because it has spin 1, it will it precesses, it's called Lama precession, it precesses an external magnetic field.
Yeah.
And they found when they looked at the hydrogen atom, they said it wobbled like a top, which is highly significant because this anticipates the discovery of spin, quantum spin, which was about 1921. This was shortly after they'd published their work on which this particular feature was mentioned, you know?
Yeah.
So that is an example where they describe things which are consistent with the quantum properties of atomic particles, nuclei. But to answer your question, no, they did not describe any wave-like behavior of matter. I think there is a reason for that, if I may just say. Unlike the person I worked with for several years, he was able to observe in a dualistic way. He could flip from one mode observation to another mode, where he would see in his field of vision lots of wave-like oscillations occurring. But he could then flip to a particle-like mode of observation. So it doesn't, micropsi, therefore, I don't think you can rule out that the wave-like notion, that wave-like behavior can't be actually observed in real time, but it just wasn't developed. I think there's two ways, two modes. You can choose, like in physics, you can choose one or the other, but you can't have both working at the same time, you know. But you can choose either mode.
That's fascinating.
Observation,
because
just as you can in nuclear, just as you can in physics.
Absolutely, it corresponds exactly to the idea in quantum theory that you either choose to look for a wave or a particle. And
well, the guy I was working with, Ron Cowan, he had a very wave-like aspect. Everything was vibrating and oscillating, shimmering. Everything was surfaces, not little particle balls, but everything was shimmering and vibrating, and also doing paradoxical things like disappearing, and then he said everything reassembled instantaneously. It sort of oscillated, it vanished, and he came back in. It was like it was coming into being and changing. It was there's lots of quantum aspects to his behavior, to his observations.
Well, Steve, thank you so much. I'm taking too much of your time, and I know there are other questions. But thank you for a most interesting talk.
Thank you,
Thank you, Bernard.
Thank you
very much.
Very much appreciated, Bernard.
Thank you, Bernard. Thank you. Should we go to Margaret B, who's been waiting for some time, and then Tim Wyatt?
Margaret. Yes, thank you very much. Yeah, Besant and Leadbeater, in my reading, and I think what I'm asking is probably connected some of the things you've just covered, but they appear to refer to more states of matter than we normally recognise. Particularly when they get to actually refer to the breakup of the UPAs, which sounds contradictory at first, but since it's the ultimate physical atom, what they say is when you break up the UPA, it goes to the astral and ceases to be physical matter. And I was wondering if you had any feel or idea for that, how that transition from the physical to the astral that they referred to from the occult field might translate to our current understanding in the physics field.
Well, I do. But I like to make the point that their metaphysical understanding of what they were seeing or describing, because let's be honest, I think it's reasonable to say that there is something that needs to be explained. You can't dismiss it as either fabricated or hallucinations. It's far too complicated, and it turns out to be the observations are too mutually consistent to be passed off by skeptics as hallucinations. However hallucinations can be shared like that, I don't know. But anyway, to answer your question, Margaret, you have to separate out their understanding, their description of what they were seeing from what actually they were seeing. That was what I have been trying to do. So I never tried to make any metaphysical assumptions which they made about what they were seeing. And I came to the conclusion that they had made a fundamental metaphysical error, and not a serious error. It was a natural error for them to have made about the extension of matter into higher states of existence, higher levels of consciousness. They believed they were highly, profoundly influenced by the Victorian notion of the ether. which was also part of mainstream science then. We was talking about 1880, 1890, It's before Einstein banished the ether. And although it had a comeback recently with quintessence. But they were typically Victorian in their beliefs of the ether, that they believed matter was a form or a form of the ether, a disturbance in the ether, you see, in some sort of universal field. It was a disturbance. And so when they came to the UPA, they thought the UPA was the atom, the final atom of the ether. But this is a fundamental error in my view, what they call the etheric aspects of matter actually refers to what in superstring theory is the hidden or an invisible class of matter predicted by a certain class of superstring theory called E8 times E8 heterotic string theory. That theory predicts that the universe is in fact consists of two universes. The total universe consists of two universes side by side. That we exist. In the physical universe is a 10-dimensional space-time sheet. We live on that sheet, but there's another sheet over here, in which physics takes a completely different form, a completely different universe, is invisible to us. It only interacts with us by the force of gravity. Okay, matter here can't pass into that. Matter here can't pass into that. So there's two distinct parallel universes here. This is the prediction of heterotic superstring theory.
Yeah, Stephen, do you want to just summarize, because there are other hands that are longing to hear you.
So that's so that is what I'm saying. That to summarize, they believe that matter, the physical UPA, somehow extended into the higher planes.
Right.
I believe this is a misinterpretation, that what they were describing is a higher dimensional aspect of the superstring. And what they were mistaking for higher planes was actually higher dimensions of space.
That's quite clear and well put, Stephen. Yes. Tim Wyatt, you have been waiting. Do you want to unmute and ask a question? Tim?
I can't unmute.
I can hear you.
Yes, okay, thank you very much. Thank you very much, Dr. Phillips, for a very interesting insight into a book which I found very fascinating for a long time. You did mention some contemporary and recent interest in this, but I gather it's not been a massive amount of research which has been done by mainstream academia or science. Has it been ever taken up by other people with supposedly psychic or clairvoyant abilities, or has it been studied by, for example, organizations like the Institute of Noetic Sciences? Has there been any other interest, is the question really?
There's been very little academic research into micro-psi. That's what you're referring to, isn't it? The micro-psi, this particular ability to magnify very small, visibly small things. There's been no academic research, as far as I know, into micro-psi. However, Hal Puthoff, who with Targ. I've forgotten his Christian name now, but Targ. Puthoff and Targ, the two parapsychologists who investigated Uri Geller. They did carry out remote viewing experiments on microdot-sized targets, where they found success remote viewing the pictures in the microdots. So they, in fact, how Puthoff did, he knows of my work, he has my book, and he did send me a paper of his. I don't know whether it was ever published, but he sent me a paper of his describing some success in remote viewing very small targets. I think they were at a distance. They weren't just local targets. They were at a distance as well as being very small, too small to be seen by the eye. But he reported to me that he had reported success in that. So it suggests that remote viewing really comes on a scale. It's not different kinds. It's really, there is only one form of faculty here we're working with, which really ties in with the historical traditional view of the cities, that this clairvoyance can be extended into the very large or into the very small. But no academic research has been done on micro-psi. Some on the other end of the scale, on the very large, yes, some research was done on that. Remote viewing of the moon, and Mars, Saturn. There was work done by that well-known remote viewer. His name is temporarily escaping me.
Peter Stewart.
Ingo Swan. He was asked to remote view the rings of Saturn. He predicted magnetic fields around the Saturn before NASA discovered them with its probe, one of its probes. And he also claimed to remote view the moon. So that the higher end has been explored by various parapsychology organizations. But of course, what I'm talking about was under the auspices of the CIA.
Exactly. Yeah.
So you can't. It's not mainstream academic work. It's covert, classified. We only know about it from what these people have.
Stephen, the other
have said.
well-known remote viewer was Professor Peter Stewart, who was a fellow of the Royal Academy of Engineers, and he has written quite a bit of stuff.
That's right. Yes.
Stuff on that. Yeah. Now, Stephen, you have a question, Stephen Dickey. Are you there, Stephen? You need.
Yes, yes, I am here. I'm here.
Right, great. Ahead.
Yes. First off, I'd like to mention that Jeffrey Hodson had done some micro-psi vision working, and he has some tapes that I got out of New Zealand. Anyhow, my question is that in the appendix of Occult Chemistry 3rd edition, they discuss electricity. In particular, they do micro-psi vision of a electronic valve, which is like a diode, but it's a vacuum tube type item, which has a grid, an anode, and a cathode. And in there, they discuss flowing of MPAs.
Your voice, your vision, your sound is getting a bit distorted.
Yes, they discuss flowing UPAs through the electron valve, and that it may even break up into Koilon bubbles before passing through the gap between.
Yes.
So that's not very high energy. How is that square with the energy it takes to remove a quark from a proton obviously making an anti-quark and in addition, because they can't be by themselves. How does that square? Because if it's such a low power, then wouldn't we be able to study them as if we studied a vacuum tube?
The question has been rather extended, so I'm not quite sure exactly what you're asking. But if I guess you're right, you're asking me, are the fact that Besant, Leibita, and Hodgson also described UPAs as able to somehow break up into bubbles and koilon. Is that right?
Yes, that's correct.
The fact that they're able to do that, how is that understandable in view of the fact that the great amount of energy that is required at CERN extent to create free quarks by smashing them together to create a quark-gluon plasma. We know that requires extremely high energies, very high temperatures, and how is that compatible with the notion that matter can split up into other things? Well, in a way, I think it's comparing apples and oranges. I don't think there's any sort of anything. We are talking about two different things here. One, which is the physical dissociation of subatomic particles into their basic constituents. But in microsci, we're talking about manipulation of images that are representations, are kind of representations in a virtual reality, But the amazing thing is that they are actually, it's part of the reality we call physical, but it presents itself as a kind of virtual reality. That manipulation whereby the particles UPA is split up into bubbles, that is taking manipulation of matter beyond the level of which physics can deal with at the moment.
Okay, yeah. Stephen, can we move on to another question, if that is all right with you?
Yes, it is.
Yeah, sorry, Steve. Yeah, two Stephens here. Yeah, a question from Una or Ivan, and then David and Sylvia. David, do you want to go first, and then we'll go to Ivan and Una? Can you summarize your question, David?
Can you hear me now?
Yes.
Yes. Okay. Sorry, I missed the start of the talk, so I'm not quite sure of the exact sort of protocol that Besant and Leibita were using in their investigations. But with remote viewing, it has been established, I think, proven that at the site that the remote viewers are addressing their attention on, there are, in fact, flashes of light. Photons have been measured by groups in China and in the US. And so I think if you're investigating a quantum particle, then probably what's happening in their work also is some observer effect that we see with quantum physics. Right. So if they had been perhaps aware of this effect at the time, maybe they might have changed their focusing their attention or things like that, but we will obviously never know.
Well, yes, but you see, I'm proposing in my own work I've been doing the last few decades. I have proposed that the very process of remote viewing the subatomic world, the quantum world, is a quantum process in itself. It has quantum repercussions. In other words, what got the Theosophists on the early examination of Besant and Leadbeater's work into trouble was that they were always looking at the subject as part of a classical worldview, pre-quantum worldview. And so what's necessary, though, is to say that, is to realize that we don't see the world as it is. We see it in a way that that we make it be, whereas we force the world into a certain mode, and that's the way it appears to us. But it's a reflection of our own consciousness, and I suggest that the whole process of viewing the world it has quantum effects, but those quantum effects are hidden. They occur before any images become stable, anything becomes visible. There's a pre-observational stage, and that's where all the quantum effects occur, where the consciousness of the remote viewer manipulates the information in matter in a way that makes that matter visible in a visual sense, truly in a visual sense, makes it visible.
Can I interrupt? There's a bit of background noise. Could anyone who is not unmuted please mute themselves?
I think everyone but Stephen and you are muted.
Right, sorry. Carry on, Stephen.
All right. Okay. All I wanted to say is sorry. Yes.
Sorry to interrupt.
All I wanted to say is that that the consciousness, what we call consciousness, is, well, I believe there's only one consciousness, but it functions at different modalities. And in remote viewing, that one consciousness is operating. In other words, it's not the mind that is creating this ability. It's not an ability of the mind. This was a point made to me by my Buddhist friends in Canada who developed this ability over many years. And by the way, I did test him. I tested him to my satisfaction. He performed these tests very well, and he convinced me that he'd have genuine powers of micropsi. But he made this point to me that that the consciousness that is observing is not his ego consciousness.
Mm.
It's not the consciousness that he identifies with. He believes it's what's called a bodhicitta. The bodhicitta, the universal consciousness. This universal consciousness operates outside of space-time. It can operate in space-time, but it's not subject to the laws of space-time. And so when he's able through meditation to flip into this higher consciousness, what Buddhists called the bodhicitta, he's no longer subject to laws of space and time, which means he can see whatever he wants to see at a distance. He can see how anything on any small, however small it is, you can see it, you see. So he says that it's not his consciousness, it's something, it's his deeper self, it's his original first consciousness. Now that's an important point that you, because a lot of mistakes are made by people who haven't defined what consciousness is, and then you go on to try and explain how remote viewing occurs, when they don't even know what consciousness is. Okay, just a reminder that did that answer some of the question, at least?
I think that's very significant. Bodhicitta, Bodhi as in wisdom, and citta, mind. That's a very profound,
universal mind.
Universal mind,
yeah.
World mind. Yeah. And thanks, Stephen, for an incredibly erudite and wonderful presentation. My apologies again for not being able to introduce Stephen properly, but the 2 points that come out are the importance of a scientific training, so that you don't confuse what you see and with your mental imagery of what you see. And I believe the essential part of clairvoyant training is to be aware of unconscious Kriya Shakti, the image-making power of the mind, and to be able to distinguish that from what you actually do observe. And Stephen's life work has taken him in all sorts of directions, but this has been a central backbone of his research and work. And I should say in closing that Stephen is far too modest to have put in his bio the fact that his research work was mentored and supported for many years by 2 international scientists of great standing. One was Ernest Lester Smith, who was a fellow of the Royal Society, who took a great interest in Stephen's work. And the other scientist is Dr. Srinivasan, who was the associate director of the atomic physics group of India's very prestigious Bhabha Center for Atomic Research. I think that is a tremendous commendation in itself of the wonderful work that Stephen Phillips has done and given us this evening. And we'll all express our heartfelt thanks to you, Stephen, for your talk, for your life's work, and we look forward to your next book, which I believe is due to be published. Thank you so much, Stephen.
Thank you.
And everyone
else
for attending.
Thank you, Eddie. Thank you.